Okay, so here we go on some examples of calorimetry. That's what we call this stuff here. Calorimetry problems. And as it turns out, calorie, of course, means energy, and metry means measure. So we're measuring energy. When we do calorimetry problems, we almost always use the same equation, which is that Q equals ms delta T. Okay, so that's my go-to equation most of the time for these kind of problems. Okay, so let's look at some examples. It says methane is a highly energetic fuel source. When it burns, it produces 802.5 kilojoules of heat. So there's a piece of information. We want to figure out how many calories is that. Oh, so here I don't have enough information to plug in to this equation because I don't have a mass. I don't know what the change in temperature is. All I have is a heat. So that means this is going to be a conversion problem. So I try to use the information provided to me in the question to tell what sort of approach I should use. So here we're not going to use this formula. Instead, we're gonna do dimensional analysis. And remember that if you don't do dimensional analysis in your work, both on the labs and on exams, then you lose points. So if you don't remember how to do this, or you need some extra practice, please make sure you go back and look at Chapter 1. Okay, so here, 802.5 kilojoules is what we're starting with. And I already know a relationship between kilo and the base unit. So that is always 1,000 of the base and 1 of the kilo. So in this case, our base is joules. So I'm going to put big joules on top, the big J there. And kilojoules goes on the bottom because I want to be able to cross these off. Okay, so you can either solve this and then do the next dimensional analysis problem separately, or you can continue to do kind of stack them up. I'm going to stack them up because I'm running out of room here, but you can do it either way. So the next relationship, I want to go from calories, I want to get to calories ultimately from kilojoules. So at this point, our unit is joules. So I want to have some relationship between joules and calories. And so in one of the prior slides, we said that there are 4.184 joules in 1 calorie. So that's the relationship I'm going to use. So whoops, I almost put it in the wrong spot. So 4.184 joules per calorie. Okay, so when I put this in my calculator, I'm going to go 802.5 times 1,000 because the 1,000 is on the top there, and then divided by 4.184. And so the answer that my calculator gives me, I'm going to write the whole thing down and then we'll figure out significant figures. The answer that it gives me is 191,802, and I know this is calories because that's the only unit that did not cancel. Okay, so I have 4 significant figures in my original data, and that's what I'm going to use to figure out the correct number of significant figures to write in my answer. So if there's 4 here, I got to have 4 in my answer. So 1, 2, 3, 4. The rest of these become zeros. So I'm going to round this basically, 191,800 calories. And that's our correct answer. Okay, so here this says glucose is the sugar we metabolize. Metabolism is, how our food becomes useful energy. It produces 720 kilojoules of energy. So how many calories is that? Okay, so I want you to solve this one. This is going to be in Top Hat. You're going to pause the video and go ahead and enter your answer for the number of calories. We're talking regular calories here, not kilocalories. Okay. Okay, so in this example, it's asking for how much heat. So I have to think, okay, which variable is heat? And the answer to that question is it is variable Q. And I keep going. Here's another piece of information. 140 grams is a mass, so that's M. And it says we're raising the temperature by 15 degrees. When it says by, that's a good indication that that answer is my change in temperature, because it means I'm starting with, say, 0 degrees and it's going up to 15 degrees. Or maybe it's starting at 15 degrees and going up to 30. It doesn't matter which one of those it is, because ultimately all I care about is the delta T, because I get to use the equation that we found earlier. Q equals MC delta T. Okay, so what I already know, just by reading the question carefully, is that I'm looking for this one, so that's what we're after. I have this one, and I have this one. And secretly, this is just a constant, so secretly I have this value as well. It comes from the prior slide. Okay, so it's our definition for our sort of heat capacity of water. So all I have to do is substitute everything into the formula and find Q. I don't even need to rearrange this formula because Q is on the left all by itself. In the future, we're going to have problems where maybe I need to solve for Q, or for something else that's not Q, so I've got to rearrange the equation a little bit. But this time that's not necessary. You'll notice that I always write units with every calculation. You should too. You'll lose points and often make mistakes if you don't write your units in. Okay, so let's just cancel everything that cancels. So grams cancels with grams. And let me see what else we got here. Oh, Celsius cancels with Celsius. So this is going to leave the unit joules, which is in energy. So that's heat is energy, and joules is a unit of energy. So we have set up our problem correctly. Okay, so here the answer from my calculator is 8786.4, and that's joules. When I look at my data, though, let's see, I got 3 significant digits there, and I only have 2 in my mass, so that means I can only report 2 significant figures in my answer. So that means that the 8 and 7 are significant, but I have to round here. So if I round that one, it goes up. So that means that I'm going to report my answer as 8800 joules. You'll note that these numbers, these ones here, don't just disappear. They get replaced by zeros, okay? So don't make the mistake of just writing 88, because that is much, much lower than the actual value that we got. Okay. Okay, so here we have a different kind of problem. It says we have 110 grams, so there's my mass. And what is the specific heat? So here we're looking for the variable C or S, depending on which one you like to write. It says of an unknown sample, that's why we don't know what the C is, because we don't know what it is. If 1402 joules, so this is heat, that's Q, because it's got the unit joules. And it raises the temperature from 246 to 85.2. So that's not quite a delta T, but it will help us get there. Okay, so to find out the delta T, I take final minus initial. So I got to read this question. When it says from 24.6 to 85.2, that means that my final is going to be 85.2, and my initial is 24.6. Okay, now, so our delta T ends up being 60.6 degrees Celsius. Remember that when you're subtracting, your significant figures are based on the place value, and so both of these numbers have a tenths place, so that means that my answer needs to have a tenths place as well. Okay, so that equation that we were working with before, Q equals MC delta T, or MS delta T, whatever you like. Here we're trying to find this variable. So if I want to do that, what I need to do is get it by itself. So I have to do the opposite. So these are all being multiplied together, M times C times delta T. So the opposite of multiplying is dividing. So if I want to move the m from one side to the other, I will divide it on both sides. Similarly, if I want to move the delta t, I will also divide it on both sides. So that means our equation is going to have q divided by m delta t equals c. Okay. I can actually double check that I did the algebra correctly because my units are going to work out perfectly, so I get those strange units that C has, which is joules per gram degree C. So if I do my math right, then I should be able to use that to verify it. So Q here we have is 1402 joules. The mass we were given is, oh, here it is, 110 grams, 110 grams. And then we figured out that delta T right here is 60.6 degrees Celsius. So we noticed that joules, grams, and Celsius don't cancel each other. So the unit ends up matching what we wanted, right? So joules divided by grams divided by Celsius. Now, don't forget to solve this bottom one first, or put it in parentheses in your calculator, because if you put 1402 divided by 110 and then equals, and then again divide that by 60.6, you might not get the right answer. Okay, so check it out with your calculator. Make sure you know how to operate with a fraction like this. So our answer is 0.210 joules per gram degree C. Okay. This has the right number of significant figures because we have 2 here and 2 in our mass. So we are all set there. Okay, so sometimes they like to throw in these density problems like this. This is actual lab data. So basically we took a beaker and weighed it, and then we added some silver to that beaker. And so to figure out the mass of silver, I have to subtract these two things. So we're going to go 277.41 minus 241.21. These are all grams. So you get 36.2 grams of silver. And then to find the volume, I have to do another delta calculation. So it's final minus initial. So in this case, its final is 43.45. And we're going to subtract the original. And so this gives us the volume of just the silver. Okay, so I can take these two things. I can take the mass here and the volume here, and I can calculate the density. So density is just mass divided by volume. So we're going to go 36.2 grams divided by 3.45 milliliters. And we get 10.49 grams per mil. I only have 3 significant figures, so really what I should write is 10.5 grams per milliliter. Okay, so in this example, we use this. I heat up 421 milliliters of silver ore. So it's not the same sample as what I had before, but I know the density because I just calculated that. So the density is 10.5 grams per milliliter. Now what's interesting about density is that's just a relationship between one unit and the next. So in this case, mass and liters. So if I want to figure out how much mass of silver I have to multiply by the volume, because that's how I can cancel milliliters on top, milliliters on bottom. Okay, so then I'm going to plug that into our equation. Q equals mc delta T. So we're trying to find Q here. My mass I just calculated. The C is given to us here. It's different because it's not water anymore, but it's provided. So our final answer here, so our temperature, change in temperature is final minus initial again, and the calculator says 9436 Okay, so our final answer is 9,400 joules.